Hey there, guys. Welcome to Unit 2, Notes 2 on Graphing Systems of Inequalities with Mrs. Matheson here. Our learning target today is I can graph systems of inequalities. In our last notes, we looked at graphing systems of equations, where we found the point of intersection, or if they were parallel lines, we had no solution, or if we had the same line, we had infinitely many solutions. This is going to be similar, but a little bit different. Systems of linear inequalities is a set of two or more inequalities on the same graph. The solution is the region where both of the inequalities are shaded. So if we look here, this is our solution because it's where both the yellow and the blue are overlapping. All right, so we're going to graph these systems. They're in slope-intercept form already for us, so that's great. Now, what I would like you guys to do is pause the video, go find two colored pencils, two different colored somethings, crayons, pens, anything, so that you can see where you have this overlapping. All right, pause the video and come on back. So I'm going to be using red for my first inequality, and I'm going to go up to +1 and do my point. And my slope I see is -x, so I'm thinking -1. So I go down 1 over 1. And just like when we did systems of equations, we filled the whole graph. We're going to fill the whole graph here with our inequalities also. All right, so now we need to decide, is it solid or dotted? Make a note to yourself. If you don't remember, you have some space on the top that if it looks like this, it's a dotted. And if it looks like this, it's, oops, I have that backwards. If it's got the little equal sign, it's solid. If it doesn't, it's dotted. All right, so our first graph inequality we have here is going to be dotted. Now remember, you can draw your solid line and then just write dotted next to it. All right, so we need to decide if we're going to shade up or if we're going to shade down. So again, jot this at the top of your page. If it looks like this, and then this is going to be shaded down, and if it eats the y, or if you want to think eats the y up, it shades up. So this one is going to be shaded down. So we're going to shade down here. And so the shading includes every quadrant. You don't have to be super exact with it. Okay, so our next one I'm going to graph is in blue. And I start with a y-intercept of 3, up 3. And my slope, 2 over 1. I go up 2 and over 1. And we're going to, again, fill the whole graph. So you want to think, you can also do down 2 and to the left 1. So we're thinking negative. This one is going to be a solid line. And because it is pointing away, it's not eating the y, we're going to be shading down here again. All right, so our solution area is actually going to be this triangle right here because it's where I have both my red and my blue shaded. And that's what all we have to do. You don't have to tell if it's a point for this because it's based on its shading. All right, so let's go ahead and graph the next two. I'm going to again graph my first one in red. So I have a y-intercept of 1. Here my slope is a positive 1, so I'm going to go up 1 and over 1 until I have filled my graph in both directions. Now we'll go ahead and look at that. Is it solid or dotted? This one is going to be a dotted line. So again, you can draw it dotted or you can write dotted. My next equation has a y-intercept of -3 that I'm going to do in blue. It also has a slope of up 1 over 1. So it looks like this. Now looking here, I'm thinking, gosh, this looks like parallel lines. It's dotted because it's not equal to. So it is parallel lines because they both have a slope of 1. But here's the thing. Sometimes parallel lines have no solution because they shade opposite directions, and other times they have a solution because they shade between the two lines. So let's go ahead and look here. In my first equation that we did in red, it eats the y up. So I'm going to think I'm shading up. My second equation in blue, it is opening away from the y, so I'm going to shade down. So we have no region that both of these are shaded in, so then this one would be considered a no solution. All right. So let's look at our next one. These ones are given to us not in slope-intercept form. So we need to convert these to slope-intercept form. We want to get the y by itself. Now remember with inequalities, if you multiply or divide by a negative, we have to flip that inequality sign. So let's go ahead and move our first one. We're going to start by moving the 3x by subtracting it. Notice this is a minus y, so it's going to stay negative y for right now. Negative 3x plus 6. I don't combine those because they're not like terms. Now I want to get y by itself, so we got to get rid of that negative by dividing by a negative 1. Remember, we divide every term. So my inequality sign does flip. It becomes 3x minus 6. So I'm just going to box that so it doesn't get lost. So let's go ahead and graph that. We're at negative 6. We're going to go up 3 and over 1 until we fill the entire graph. And this one's got an equals to, so it's going to be a solid line. And it's pointing away, so I'm going to shade below. All right, our next inequality is nice because it's positive y, so all we have to do is minus the 2x. So we get y is less than or equal to negative 2x plus 4. We're going to start up at positive 2. Oops, positive 4, excuse me. Positive 4. We're going to go down 2 and over 1. And we're going to the right when we go over. Again, we're just filling our entire graph. This one is also a solid line because of this equal sign here. So connect those. And then it opens away, so we are also shading below. So shading below, we're looking here at a solution area of this right there. Okay, so let's look at number 4 here. Number 4, that's an interesting first inequality. It says x is less than or equal to 3. Now there's no y in it, so that means we're never going to cross the y-axis. So I'm going to graph this in red. I have an x. Here's my 3 on the x, and it's never going to cross. The only way we can have a line that's never going to cross is going to be straight up and down. Okay, and this one is a solid line because it's got that equals to. So think about it. Where are all my numbers on my number line that are less than 3? Because there's not really an up or a down of this line. There's just a left or a right. So all my numbers that are less than 3, well, if I look here, 2 is less, 1 is less, 0, negative 1. These numbers here are all less than 3. So I'm going to shade all to the left side. My next inequality is a simple of subtracting x. So we have y is greater than negative x plus 2. So we have a y-intercept of 2. Negative x, think of negative 1 slope. So we're going to go ahead and fill the entire graph with a negative 1 slope in both directions. This one is a dotted line because there's no equals to. And it opens towards the y. It's eating the y up. So I'm going to be shading up. My solution area for this one is going to be this area right in through here. Okay, guys, so I want you guys to come done with these two problems for class, problems 5 and problem 6. They are already in slope-intercept form for you, and I just want you to be thinking about this one right here. There is no x, so it's never going to cross the x-intercept or x-axis. So look back at problem 4 to help you with that one. All right, we'll see you guys in class.